Okay, welcome back, and we're going to look at the next acceleration versus time graph example. And if you think this looks familiar, it's because it is familiar. It's the velocity versus time graph we did an example before. So it's this object that moves 12 seconds as shown in the velocity versus time graph. Calculate the acceleration in each of the four segments of the graph. So the segments they're talking about: 1, 2, 3, and 4. Okay. So just the different straight lines. One, acceleration, there's no change, there's no rise, so it's equal to 0 meters per second squared. So when it's just a flat line, this is none. So just need to start recognizing that. For part 2, we have a equals. I might do the whole points for you in this one rather than just looking at the rise over run. So this point here is 6, so it's our x coordinate, and 6 for our y coordinate as well. This point here is 4 and 3. Okay, so remember it's y2 minus y1 over x2 minus x1, which equals, so this is our y2 x1, sorry, and y2, this is our second points, aren't they? So this is our x1 and y1 there. So x1, y1 here, x2, y2 up here. Alright, we'll get there eventually. It's actually easier just to do rise over run, isn't it? So y2 is 6 minus 3 over x2, which is 6 minus 4. And if you remember from when we did this in the other example, it ends up being 3 over 2, so it's equal to 1.5 meters per second squared north as well. Okay, so 3. So it's for this whole section down here. Okay, but you can calculate any part of the gradient. So we can use this time. This one, we can use 6 and 6 as our x1, y1. Let's use this point here, and that is, what is it? It is x is equal to 8, y is equal to 0. Okay, so this can be our next point for 3. You can use this point down the bottom if you want as well. Any point along that line. So a is equal to, so 0, it's our y2 minus 6 over x2, which is 8, minus 6, which equals negative 6 over 2, which is equal to negative 3 meters per second squared. And again, north, so you could say that is 3 meters per second squared south. Okay. And finally, for our fourth point here, a is equal to 0 again, because it's a flat line, so there's no rise, which means a is equal to 0 meters per second squared. And for some reason, that I don't know where that came from. Anyway. Alright, so use these values to sketch the corresponding acceleration versus time graph. I've kindly put in a 0 point for us. Okay, so let's just have a look then. Our first one is 0 meters a second. How long does that go for? It goes for 4 seconds. So our first point is 0 and it goes for 4. And I'm going to say, what do we want? 2, 4, 6, 8, 10, 12. It goes for 12 seconds. So every point is going to be worth 2. 2, 4, 6, 8, 10, 10, and 12. Okay, so it's 0 for 4 seconds. So this can get a bit messy sometimes. Sometimes I like to draw the, put the time down the bottom, but anyway, it's better if we can have it on the axis. So that's the first point, 0 to 0 meters per second for 4 seconds, and then it goes from 4 till 6, and it is 1.5 meters per second north, so a positive 1.5 sec for from here to about here. Hopefully that's straight. Get our ruler in there. Let's do a straight line across. Okay, 1.5. And we can do these little dots to show it's connected. Okay, so 1.5, and then from the next 2 seconds, it is from 6 to 8, it is negative 3. Quite a big drop. Oh, wait a minute, that goes a bit further than that, doesn't it? It actually goes from 6 we just calculated it from 6 to 8. It actually goes from 6 to 10. Okay. So from 6 to 10, it's -3. There we go, -3. And then for the last 2 seconds, it's 0. Back up to 0 again. That's not a very good looking 12, is it? But anyway, might put a line straight through it. Let's see. No, it's underneath. Okay, so that's our graph, and we just want to draw in our lines, dots. Usually we just do dots in there between them. And normally we have an axis line across that 0, but it's probably easier to see without it in this case. And that's it. Okay, so that's all our graphing motions one. The next topic will be on forces and motion, or forces, Newton's laws.